everybody. Hope you had a good weekend. This is a quick review of some of the areas I'm afraid you might have forgotten about quadratics, particularly at the beginning. First part pertains to graphing. And I just want to double check that you remembered how to graph them. So you'll notice I have a couple problems up here. One is in vertex form, one is in standard form. If I am in vertex form and I ask you to graph it, I may ask you also to identify all the necessary parts, so let's do that first. Where would you find the vertex? Well, hopefully I'm hearing it would go right 4, because you would change the sign in the parentheses, and up 6. So we have a vertex of 4, 6. If I said what direction will it go in, you would look at the front number and see that it's negative, and so we would know it's going to go down. The line of symmetry, you'll recall, is a vertical line always. So therefore, it's always written x equals. If you forget the x equal, you're going to cost yourself a whole bunch of points. But how do you know what it should equal? And it always equals the x coordinate of the vertex. So since that's 4, we would have x equals 4. And then last but not least, we would want to know whether it's going to be wide, narrow, or normal. Okay. Our coefficient in front is a 3. The negative doesn't matter. Hopefully you'll remember that if it's a number larger than 1, it's going to go up fast, so that's going to make it narrow. If it was a fraction value between 0 and 1, then it's going to go up slowly, and it's going to be wide. The positive or negative has no impact on the width. When you actually want to plot it, you'll recall that you simply plot your vertex at 4 over and 6 up. And then you have to do your t-table. Our good friend with the 1, 2, 3, and the y-coordinates are always squared, so it's 1, 4, and 9. Now the question is, do I leave it 1, 4, 9, or do I have to change those y-coordinates? And yes, since I have a negative 3 in front, I have to change them all and multiply them all by negative 3, so that will give me negative 3, negative 12, and negative 27. I'm probably not going to plot 27. So from my vertex, that's telling me to go over 1, down 3 on both sides. Then from the vertex over 2, down 12, which would be these two mirror points. And I can get down 27 on this graph paper, so we'll leave that one off. And so therefore I would have a very thin parabola. Hard to try to round it off, don't make it a sharp point. And that would be graphing a parabola in vertex form. Now you'll hopefully remember that graphing in standard form is virtually the same thing, except you have to figure out the vertex in a different way. And since we've been doing that for several days now, you'll hopefully remember that when it's in standard form, you need to do negative b over 2a to get the x-coordinate. So in our case, negative 4 would be b. 2 times a is a half. Well, this actually turns out pretty sweet because those 2's cancel, and I end up with an x-coordinate of negative 4. Now, how did I get the y-coordinate of the vertex? Well, hopefully somebody out there is saying, sub it in, sub it in. So I'm going to sub negative 4 into this equation and see what I get. 4 squared would be 16 times a half. That would give me 8 plus negative 16 plus 5, which would add up then to be negative 3. So in the end, I have a vertex at the point negative 4, negative 3. If I asked you for the direction, you would still look at the first coefficient on the x squared. That's a. Again, it's a positive 1/2. Since it's positive, it's going up. If I asked you for the line of symmetry, you would immediately shout, x equals, and it would equal the x-coordinate, which is negative 4. And then last but not least, if I asked you for the width, we would find that the width is going to be wider because it's a fraction. We're going to get a 1/2. So that 1/2 is going to make it go wide. And to prove that point, we will actually create then our t-table. We're going to plot our vertex at -4, -3. And then we're going to do our standard t-table with our 1, 2, 3, 1, 4, 9. Do I need to change the y-coordinates? And the answer would be yes. There's a 1/2 on this, so I need to take them all times 1/2, which will make that 1/2, 2, and we'll go decimal here, 4.5. So from my vertex, I would go over 1, up 1/2 on each side, then over 2, up 2. From the vertex, over 3 this time, 1, 2, 3, up 4.5. Put us up here above the x-axis, and that's enough points to get a curve. Now, the other thing I threw in here, you'll notice I threw a less than sign, so this is an inequality. Do I need dotted or solid line for this parabola? And you should say need a dotted one. It does not have an equal sign. And the other thing is we need to shade, and this was the part that was bugging a few of you. How do I know where to shade? It says y is less than. You can test the point, but quite frankly, on quadratics, testing a point is a pain. It's easier to just look at it. It's saying y-coordinate is supposed to be less than this parabola. So pick any point on this parabola. A y-coordinate says less than, y-coordinates go up and down, so if it's less than, it's going to be a y-coordinate below this graph. I personally usually use the vertex because it's a really easy place to do this. If you pick a point below on the vertex and you go less than, you're going to be below, so you're going to be outside. If you pick any of these points on the parabola and go less than, you're going to be on the outside. So we're actually going to here end up shading everything. I need a much wider pen here if I'm going to get this all shaded. And so we're going to shade outside the parabola. If you recall, you either end up shading outside or inside the parabola once you get it figured out. And so this isn't the neatest coloring, but we get the point. Okay, so that's graphing. I guarantee you that you'll be asked to graph at least bare minimum 2 that I'll have you do 1 in each form, and there will certainly be one with an inequality. That takes care of the first page of your review sheet. At the top of the second page, I give you some problems where I give you information and I ask you to find the equation of the parabola. And these also can cause some trouble. This first one, I told you the vertex is at -3, 5, and it goes to the point -1, -7. I showed you 2 ways to do this before, and I'll show you 2 ways again. Of course, if you know the vertex, you know you can put it in vertex form, and you get most of it filled in. If this went -3 to the left, then in the parentheses it had to be x plus 3. That sign's always opposite. Since that's a +5, when it's on the outside, we don't change the sign. It went up 5. Our problem is, what's A? What's the number in front? And there were 2 ways to do it. You could go to a graph, and I could plot it. Here's the vertex at -3, 5. If I have a point at -1, -7, down here, wow, that baby's dropping, which means I had a mirror point over here as well. So I could look at it that way and go, okay, normally from -3 over to -1, that's over 2. I'm going over 2 and down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my t-table, normally going over 2, it should have been a 4. I, instead, ended up going down 12. So consequently, what did I multiply 4 by? And the answer would be -3. So -3 must be the number we need in front. So you can do it that way. The other way, some of you prefer to do it algebraically. If you prefer to do it algebra, fill in the coordinates of that point I gave you. Y is -7, x is -1. And you can then solve that way. Negative 3 plus 1 will be 2 squared. That's 4. So you have 4a plus 5. If I subtract 5, I'll have negative 12. Divide by 4, a is negative 3. So either way I do it, I end up with a being negative 3. So my final equation, I'm running out of space here, my final equation then ends up being y equals negative 3 times the quantity x plus 3 squared plus 5. Whichever way you want to do it. Okay, the other one we did where we went backwards, where I gave you information and asked you to find the equation of the parabola, was I actually gave you the roots, meaning the solutions. So these are the answers once you've solved the quadratic. Consequently, that means you've solved the quadratic and you got x equals 6 and x equals negative 3/5. If you recall, to work these, we did factoring backwards. We turned it back into factors by bringing the 6 over. Now, 3/5, we wouldn't have had a factor that had a fraction in it, but we know the 5 would have been over here on the x. It would have originally been 5x equals negative 3. So the factor would have been at 5x plus 3. Once you recreate the factors, you just have to FOIL them back together to get the equation. Now, the most common mistake comes at the end, where you're going to lose half a point if you forget it. I said write an equation, so don't forget your equals 0. You do need to FOIL this out and get it back to standard form. So I am FOILing here. And if I add up my like terms, I should have ended up with 5x squared plus, minus 27x minus 18 equals 0. And there would be my equation that has those roots as its solutions. Finally, a couple other things I want to ring your bells about. Completing the square. Been a few days since we did that one. You'll notice here, I'm figuring that you all pretty much had a good handle on how to solve by factoring. And you had a pretty good handle on quadratic formula. You've been doing that a lot too. So I don't think those two are major issues. But I do want to do completing the square one more time to make sure you remember that one. If you recall, to complete the square, can I have the 5 out front? Can I have that coefficient? Yep, and the answer is right. You can't do that. You have to get rid of the 5 by dividing it. But remember, this is the one and only time you ever divide is on completing the square. Don't do it on any other problem. So I'm going to divide by 5, which will give me x squared minus 6x plus 11. That's a little better. I want to complete the square. Is 11 the right number that should be sitting there? And nope, it's not. So I'm going to ditch it over on the other side. Now I need to fill in and complete the square. And there's the key. Do you remember how to figure out what number goes here in order to make this trinomial be a perfect square binomial when we factor it? In a moment, we want to write it as something quantity squared. Well, hopefully it's coming to you. You take half of the number in front of x. So I'm going to take half of this negative 6. Half of that would be negative 3. And you square it. So squared will make it positive, and it'll be a positive 9. Now, what's the most common mistake people make? Yes, if you added 9 to the left side, you have to balance your equation. So you have to add 9 to the right side to keep things equal. So I now know that the right-hand side is equal to negative 2. The left-hand side is a trinomial, which if I factor it, I'll get the same factor twice, or in other words, a binomial squared. How do I know what sign to put in it? And yes, whoever said first, you're correct. It's the first sign, so it's going to be a minus. The number I got half was 3. That's the number I squared to make 9, so it's going to be x minus 3 squared. Now, last step, how do you get it solved for x? Yes, you're in the square by square rooting it, so we end up with x minus 3 equals, can I break down this root? Well, I can't break down 2, but I sure better take the negative out and make it I. And, of course, I always put a plus or minus on it. Last step then, add the 3 over, and you have 3 plus or minus I squared of 2 as your solutions to that quadratic, then by completing the square. Finally, just a quick thought on solving by calculator. If you remember, we graphed our parabolas, and then we solved them, and we found out the solutions are where on a graph. Not the vertex, but the solutions. And we discovered that, yes, the solutions are where it equals 0, which are the x-intercepts. So you have to find the coordinates of those 2 points on your calculator. And I've written the steps here. You put your equation in F1 and graph it. If you cannot see both x-intercepts, you need to zoom out so you can see both places it's crossing the x-axis. You do not need to be able to see the vertex. And then if you do menu, analyze graph, and choose 0, which is number 1, you'll have to do it one at a time. You will highlight from left to right over one of the x-intercepts, and then do the same for the second one, and you will have the 2 solutions. That should take care of it. Your test, is, as many of you have already commented, there's a lot of material for this test. This test is on Wednesday. At most, there'll be 1 problem of each kind, and probably not even all the problems will be there, or some of them may be extra credit. Okay, this is not a test to take lightly, so please, please, please study for this test and do your review sheet. Now, work hard the rest of the hour and put your time to good use. You can finish your partner problems and work on your review sheet. Good luck.